the launch of EKS service, the management of your Kubernetes control plane goes from your internal infrastructure team to Amazon. Let's now quickly create an EKS cluster. As prerequisites, we'll first set up your VPC and an EKS service role, and then we'll configure kubectl and AWS CLI tools. Let's head to the documentation page. You'll find a quick link to the CloudFormation console. Select the Oregon region and create stack. You can use a template URL for VPC creation that we have on the documentation page. It's pre-populated with all default values. Feel free to leave them as is unless you specifically want to change them. I'll just add a key value pair in order to tag my stack resources. Acknowledge and create. In just a couple of seconds, you'll see all the resources defined in the template come up. Creation is complete, and we can check in the outputs tab the output values that we will actually need in the latter step. Now that VPC creation and the EKS service role creation is complete, we have to configure our tools. First in order is kubectl. Kubectl has been modified and a client has been added to kubectl in order to make kubectl work with Heptio AWS Authenticator, which is an open source project. The reason we did this is because for an administrator that's already used to Amazon IAM credentials, it becomes a headache to manage Kubernetes credentials separately. Additionally, in Kubernetes, you have the concept of service accounts and single users. And by using Heptio's AWS Authenticator, the whole process remains seamless for an AWS administrator. And they also continue to use features like two-factor authentication and CloudTrail going forward. So now that we have kubectl configured, we'll now set AWS CLI to work with Amazon EKS. So first we download a JSON file that has the descriptions of all the CRUD operations allowed on EKS. And then we configure Amazon CLI to operate with EKS APIs. There you go. All our prerequisite steps are complete. So now we will create our first EKS master cluster. In order to do that, we have a direct link to the EKS console. Create cluster. You can give your master whatever name you'd like. Associate this master with the VPC that we just created. So enter the VPC ID and the role on of the service role. By adding this role on for the service role to the master cluster, you allow Amazon to maintain, monitor, keep the cluster up and running at all given points in time on your behalf. In just a couple of seconds, the cluster will be up and active. Now that the Amazon CLI has been configured to work with EKS, the next logical step is to make kubectl work with EKS directly. In order to do that, we provide you with a default kubeconfig YAML, and all you have to do is modify this kubeconfig to reflect the values of the master cluster that you just created. So first, modify the cluster ID, which is essentially the name of the EKS master that you generated. And second step would be to update the server endpoint where the master services can be queried. So if you go to the console and click on the cluster name, you can find the endpoint, update it onto the config file, and there we go. You can export this kubeconfig file to the variable kubeconfig and you're ready to work with EKS service. Next step, we have to launch and configure EKS worker nodes. In order to do that, we head to CloudFormation console. We select the Oregon region and we use a pre-configured CloudFormation template to create a node group. So let's hit create stack, copy paste the template URL, and thereafter we have to enter some parameter values to generate the node group. The cluster name is the same as the master cluster. Key name is essentially an SSH access restriction that you can place on the node group. I have pre-configured key names, so I use that. Add the master endpoint. You can modify the auto-scaling policy of the node group, provide it with a unique identifier. This means that you can have multiple node groups talk to the same master cluster, if that's how your environment is supposed to be designed. For the node army, or rather the image ID, add the army value that we provide in the documentation. Essentially, this army is pre-configured with all the tools that you will need on your individual nodes, networking, kubelet, other binaries or tools that you might need on the node. Add the VPC ID from the first step and then acknowledge and create. In just a couple of seconds, the creation of the node group will be complete. There you go. As a next step, we will download a config map that we have hosted on S3. This config map is essentially required to complete the authorization process and map your Kubernetes roles with the Amazon IAM roles on all of the node instances that were just generated as part of the node group. I'll go to the CloudFormation template and copy the ARN, which has my IAM information, into this config map. We'll keep the use case extremely simple and apply this config map onto the Kubernetes cluster. Looks like the Kubernetes nodes are coming up just fine. Let's double check using kubectl get nodes. There we go. Now that the cluster is ready, we have to add DNS information to the cluster for service discovery. So download the template available on S3 and then modify the YAML with the right endpoint for the EKS service. Make sure that this variable is just the endpoint information without the HTTPS. Copy it from the EKS console, update the file, and then apply it against the cluster. Let's deploy a guestbook app service backed by Redis on the cluster. Create the Redis master replication controller and service first, and then we apply the Redis slave RC and service to the cluster. We'll now create the guestbook RC and service, and then figure out the ELB endpoint from where we can access the service. Let's use a browser to access the service. There you go, and this brings us to the end of our demo.